value function, recall, in its basic form is this: f of x equal absolute value of x, right? Where these two bars surrounding the real number, these two bars, they mean absolute value, right? This is red, absolute value of x, absolute value of x. What does this operator do? For any input value x, the output value, absolute value of x, is the value of x regardless of its sign. So it just basically drops the sign of the real number, right? And outputs just the value, For example, the absolute value of -3, dropping the sign, is just 3. The absolute value of the real number, -5.71, again, dropping the sign, whatever it is, positive or negative, 5.71, right? Absolute value of 8. There is no sign, Professor. Well, if there is no sign, it's understood that there is a positive sign there. Drop it, 8, right? Absolute value of 0. 0 doesn't have a sign. It's neither positive nor negative. So by agreement, mathematicians just say absolute value of 0, 0. Notice, guys, that the absolute value operator basically makes the number positive, right? We can see this, or just outputs just the value without a sign. Now, how to define this absolute value function using piecewise functions that we have covered before? It says here, now we can define the absolute value function as the following piecewise function. This is going to be a little bit tricky. I will explain if needed. Mathematicians define the absolute value function this way: absolute value function of x equal to x itself if x is positive or equal than 0, bigger or equal than 0, right? And its opposite if x is less than 0, if x is less than 0. For you to see this, guys, let me take this example, right? Look, if your number is positive, when you take the absolute value, what appears here, the same, right? Same, right? However, and even if you use 0, right? 0, the absolute value of 0 is still same. This is what this part means. If the number is positive or 0, the output is just the same. However, if the input value is negative, just like in here, -3, let's say, what you write here, 3. But what is this 3 compared to the input value? It's not the same, right? Like before. It's the opposite. So that's the whole idea behind this definition, guys, that sometimes causes confusion. The output compared to the input, opposite. That is why mathematicians put this negative sign there. You follow, guys? Everybody clear with this definition? Okay? Yeah, that is the definition of the absolute value function. But now we're going to do some transformations with these absolute value functions. Or first in its basic form, and later we will take more challenging forms. Now, assuming that we have understood the definition, let's allow ourselves some input values such as 0, 1, 2, -1, -2, and let's calculate what is the absolute value of 2, that is 2, absolute value of 1, that is 1, absolute value of 0 is 0, absolute value of -1, 1, absolute value of -2, 2, right? So for 2, we have 6 parameter 2, for 1, 1, for 0, 0, for -1, 1, for -2, 2. If you take these order pairs, 0 goes with 0 here, 1 goes with 1 here, and you know, set them on a XY coordinate, you're going to get the following. 2 goes with 2 here. -1 goes with -1. So we have something here. -2 goes with -2, something here, right? What you're gonna get, guys, is, but these are positive, so we have to put it up there. The absolute value of -1 is 1, right? The absolute value of -2 is 2. The absolute value operator makes the numbers positive, right? So therefore, you will get this, right? You're gonna get this V as in victory shape, and that should be from now on the graph of our absolute value function, right? It will look like a V in victory, right? Diagonal here, diagonal here. Diagonal lines, right? Very good. So now we're gonna add this absolute value function to our set of parent functions, right? So one more function of x equal absolute value of x, its graph is this V as in victory, okay? Okay, now transformations of the absolute value function. Example 1, suppose they ask you to graph this f of x equal twice absolute value of x minus 3 plus 4. Let's do this together. All right, start as usual with something that you know. We know the absolute value function, right? We know its graph. So start with that. We know that the graph of the absolute value function is just this. F of x equal absolute value of x, right? Now, because of this number 2, notice since 2 is greater than 1, the rule for non-rigid transformation says that we have to stretch vertically this graph, right? Stretch vertically this graph. So we're going to stretch vertically this graph. Remember, keeping this guy fixed. Why this guy fixed? Because it's 0, 0. 0 times 2 is 0. Doesn't move, right? This doesn't move. But out of stretching vertically, I'm going to write here vertical stretch. Vertical stretch. The new graph will look like this, right? And what really matters is the main shape, right? But of course, since it's multiplied by a factor of 2, if you want to be precise, right, you can say, okay, the slope here is going to be 2 to 1, right? 2 to 1. I'm going to write it here in case you want details. 2 to 1 now. From before was 1 to 1, right? Before was 1 to 1 here. But now it's 2 to 1 because of this. All right, we stretch this vertically. Next, there is now number -3 here. What is this telling us? This -3, since it's associated to the input value, this is called a horizontal shift, right? And what is it going to do to our parent graph? Move it 3 units to the right, right? We kind of do the opposite of what this suggests. This is left number line, but we'll move 3 units to the right. And this +4, finally, the +4 there, this +4 is what we call a vertical shift, right? A vertical shift moves it up intuitive, right? 4 units. Right? So 3 things we have to do, right? The vertical stretch, we just did it here. But after that, we have to do a horizontal shift, 3 units to the right, and a vertical shift, 4 units up. If you do that, guys, for the horizontal shift, 3 units to the right, I go 1, 2, 3, let's say, right? And then 4 units up, 1, 2, 3, 4, right? Up. This point is important. This was 0, 0, but in the end, this should be 3, 4, right? 3, 4, important point. Now there, I have to draw this V as in victory, but now it's steeper, right? It's steeper. Because now you're gonna go like this, more or less. Right? The new slope is gonna be 2 to 1, right? Because it's being stretched vertically by a factor of 2. Follow, guys? So this is the final graph. This is f of x equal absolute value of x minus 3 multiplied by 2 plus 4, right? Plus 4. This is this graph. Very good. Moving on, another example here before we go over the worksheets. Graph this g of x equal negative 1/3 times absolute value of x plus 4 minus 2. Quickly, we identify that this negative sign is going to reflect our parent function, the graph of our parent function to be precise, about x-axis, right? X-axis. So if you start as usual, right, with your parent function here, g of x equal absolute value of x, this negative sign is telling you, you have to take now the reflection, right? You have to do this now. Reflection, whatever is positive becomes negative, whatever is negative becomes positive, right? So this is what we have to start with, minus, right? Yeah. But not only that, notice that there is this negative, not negative, positive 1/3 there attached to it. The negative sign was already considered by this reflection, but this 1/3, since 1/3 is between 0 and 1, it's a proper fraction, this is going to compress the graph of our parent functions by a factor of 1/3, right? Vertical compression there. And as usual, keeping this point fixed, because this 0,0 is not going to go anywhere by multiplying it by 3, right? Or 1/3 in this case. All right, so as a consequence of this compression, notice that this guy will be wider, right? Like this. And finally, then after applying the vertical compression, we are going to do the horizontal shift here associated to this 4 units. Moves it 4 units to the left, right? To the left, because opposite to what this suggests. And this guy moves it down, right? Moves it 2 units down, right? So move this vertex of this absolute value graph 4 units to the left, 1, 2, 3, 4, and then 2 units down, 1, 2, right? So here is where this point is going to appear, right? Originally, this was 0,0, but it will end up at -4, -2 here, right? Follow, guys? And there, reproduce this. So that's it. And then if you want to compute the slope, should be now 1/2, right? The steepness, you can do that too. 1/3 to be precise, right? No 1/2, 1/3 now. 3 to 1, right? 3 here, 1 here, right? Something like this. If you want to specify the slope, right? But it's not going to be needed for the worksheet, perhaps on the homework. All right, guys. So now, before we go over the exercises, let me show you how to do this, but backwards, okay? Backwards. We did transformations, right? And we came up with a final graph, like in here, right? But what if they give you the final graph and they ask you to figure out the formula, the rule for the function, okay? This is sort of some backward thing I'm going to show you. You're going to use this on your homework. Suppose they say, find the equation of the function whose graph is shown on the left. The final graph is this. Figure out what is the formula for the function. Well, you start by saying, okay, I notice that this vertex has coordinates 1, 2, 1 here. So this is -2, 1, right? -2, 1. It means that the original vertex of the absolute value function was moved 1 unit up, 1 up, and 2 units to the left, right? To the left, to the left, right? So no hard to see. I hope, guys, that this function f of x should be the following. There's no stretching or compressing, because notice the slope is 1 to 1 always, 1 to 1 here, 1 to 1 as the original absolute value functions graph, right? So the graph will be x. I have to write some number here. I have to write some number outside, right? For this number, I look at the horizontal shift, right? It was moved 2 units to the left. So I should write here the opposite, +2, right? +2. This 1 unit up, intuitive +1, +1. You follow, guys? So this is how you recover the formula from the graph, from the given graph. One more example here, and then we'll go to the worksheet. This is another one. So here, example 4. Find the equation of the function whose graph is shown on the left. This. Again, quickly go to the vertex. This is 1, 2, 2. This is 1, 2, 3, 4, 2,4, right? So this is saying that your function, this the vertex was moved 2 to the right, right? 2 to the right. And 4 units up, right? 4 units up. 4 up, right? So the function should be this, right? First, let's just get the basic form, and then we'll deal with the steepness. X, 2 to the right. So I have to write here the opposite, -2, right? -2. Remember, horizontal shifts are counterintuitive. Now, 4 up is just +4, +4. Now, everything okay, except that the steepness is not 1 to 1, it's 2 to 1, right? 2 to 1. This original V as in victory has been stretched, right? Vertically. And not only that, look, the orientation also of the V, which is originally this, has been flipped. So there must be a negative sign in front of this, right? Minus for the reflection. Now, since this has been stretched, you gotta catch the factor. By what factor this was stretched? Well, by a factor of 2, right? Because now steeper, stretched by a factor of 2. So this should be -2. -2 times x -2 plus 4, right? How I got this guy -2? Because of the steepness. Notice now this the slope in this is 2 to 1, right? Slope. This is associated to this. Okay, guys, let's go to the worksheet so we can finish this up. This is going to serve you for your homework. Look at these examples. I have attached a video. It's very tricky, right? But I have attached a video for you to watch in case it's needed. Let's go to some exercises. So let's see. Let's start with something straightforward. What should be the graph of this? Anybody in the chat? Try to do it, please. G of x equal -2 multiplied by the absolute value of x. Remember, -2 reflection, right? So about the x-axis, right? It's like placing a mirror on the x-axis. And these two indicates stretch, right? Vertical stretch. Stretch by a factor of 2. Yeah, vertical stretch, and then flip it, right? Flip it, and that should be your final graph. So which one do you think should be the final graph? Right in the chat. This is the original one, right? Aha, I see. Movement on the chat. Very good, very good. Gabriela, yeah. Aha. Let me check. Very good, Gabriela. Yeah, you made my day. Yeah, Mohina also. Very good, very good, very good, you guys. Yeah, it's, as you can see, right? If you know the rules, you don't need to know the detail, the steepness, right? But clearly here, if you do the reflection, this is gonna go like this, right, for a moment. And then if you multiply by 2, this is a vertical stretching, right? So finally the graph may look like this, right? Very good, guys, very good. Just this, 2 to 1, right? 2 to 1, the slope, the steepness. Excellent. Moving on, what about this? Could you figure this out? Number 2. Y equal negative x plus 2. Here we are dealing with reflection, the negative sign up front, right? We are dealing with, let's use a different color. Dealing with reflection, and we are dealing with this one, horizontal shift. Remember, horizontal shift counterintuitive. Yeah, we start with this as usual. This is y equal absolute value of x. Aha, I see number 2. Mohina, excellent, excellent, very good. Excellent, excellent. Very good, you got it. Yeah, let me explain, right? This is the original graph for y equal absolute value of x. The negative sign means that we have to reflect this about the x-axis. We get this, right? And then this plus 2 affecting the input value means you have to shift the graph horizontally 2 units to the left, right? To the left. So this moves to the left. So finally, 2 units to the left will be here. Very good, guys. Very good. So this is this. Excellent. Let's see if we can do one more. Yeah, this one is straightforward. This one. Let's finish up with this. Try this. G of x equal 1/2 of x plus 4 minus 3. And the hint is this, since 1/2 is between 0 and 1, this is a vertical compression. By a factor of 1/2. This horizontal shift, right? This vertical shift. I see someone posted an answer for number 4. Let's check. I didn't show the rest, right? So I should show everything. Sorry, guys. Yeah. Now try to look for the answer. Sorry, I didn't show the last choice. Yeah, let's do it together because we're running out of time. The 1/2 is going to apply compressing, right? So, I see students are posting answers. Yeah, now Mohina is good. Yeah, it's just that you didn't see this one, right? Very good, excellent. Yes, you got it. Yeah, this vertical compression will turn this VS and Victor into this, right? +4 means you move this to the left 4 units, right? So somewhere there, here, right? 4 units to the left. -3 means 3 units down, 3 units down, right? So finally, this graph will appear 3 units down here, 1, 2, 3, somewhere there, right? And that is a perfect match with this. Excellent, guys.